With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
In a container of negligible heat capacity, 200 gram ice at 0 degrees Celsius and 100 gram steam at 100 degrees Celsius are added to 200 grams of water that has temperature 55 degrees Celsius. Assume no heat is lost to the surroundings and the pressure in the container is constant at 1 atm. Find the amount of the steam left in the system. Okay, so what I'm going to do is, since there is no heat being exchanged between the surroundings and the system, the heat that would be required to convert the given water into steam or the given ice into water will all be supplied from within the system. So what I can do is, if I add all the heats that are being consumed and all the heats that are being supplied, if I add them up, it should turn out to be 0. So let's start. So 200 grams of ice will take some heat energy for converting into water. So that is minus 200 grams into the latent heat of fusion of ice, that is 80 calories per gram, plus 100 grams of steam will give away some energy to convert into water. So 100 grams into latent heat of vaporization of water, 540 calorie per gram. Now let's assume that the final temperature of the mixture is capital T. So the water that is obtained from melting of ice would be 0, will have to raise itself from 0 degree to T degree Celsius. Or since the specific heat capacities are mentioned in Kelvin, we might need to convert it into Kelvin later. 0 degree into specific heat capacity of water is 1 calorie per gram per Kelvin. So we'll take that in mind, plus the heat that would be released by the lowering of temperature of the water that was obtained from the steam. Since that water is obtained from the steam, it would be at a temperature of 100 degrees Celsius. So 100 grams into specific heat into 100 degrees Celsius minus capital T degree Celsius, plus the water that was present in the system itself. So 200 grams into 1, that is the specific heat, into 55 minus capital T. This all should be equal to 0. Now let's simplify this equation. So minus 16,000 plus 54,000 plus 200 into 273 minus T for converting into Kelvin, plus 100 into 373 minus capital T, plus 200 into converting 55. 55 would be 328 Kelvin minus capital T is equal to 0. Now let's take all the constants to one side. 54,000 plus 200 into 273 plus 100 into 373 plus 200 into 328 is equal to 200 times capital T plus 100 times capital T plus 200 times capital T. So this gives us minus 16,000 plus 54,000 plus 54,600 plus 37300 plus 65600 is equal to 500 capital T, which gives us 500 times of capital T is equal to 195500, which means capital T is equal to 391 Kelvin. Now, the boiling point for water is 373 Kelvin, which means that the temperature of this mixture is going above 373 Kelvin. What that implies is that the mixture will continue to heat up until 373 Kelvin, and after that some part of that mixture will convert into steam. And if you look in the question, that is the steam that we need to calculate. So let's assume the mass of the steam to be small m. So I will once again write the equation of all the heat that is being exchanged within the system, but this time I will add one more term, and that term would be m times 540 to account for this negative, to account for the energy that is being taken away from the system by the mass m to convert back into steam. So let's write our equations once again. Minus 200 into 80 minus 200 into 80 plus 100 into 540 plus 100 into 540 plus 200 into 0 minus T plus 200. 0 degrees in Kelvin is 273 Kelvin minus capital T. Now the capital T that I will use would be 373 Kelvin and not 391 Kelvin. It is because, as I said earlier, the mixture will remain constant at the temperature of 100 degrees Celsius, and now instead of that heat being used to increase the temperature, that heat will be used to convert the mass m into steam. So 273 minus 373 Kelvin plus 100 into 100 minus T. So 100 into 100 degrees is 373 minus 373. So this term will eventually turn out to be 0 plus 200 into 55 minus capital T. So 200 into 55 is 328 minus capital T would be 373 Kelvin, and the term to account for the conversion into steam minus m into 540 should be equal to 0. So now let's solve this equation. So minus 16,000 plus 54,000 plus 200 into 100 negative, plus this term will become 0 plus 200 into minus of 45 is equal to 540 small m, which means 540 small m is equal to minus 16,000 plus 54,000 minus 20,000 minus 9,000, which gives us m is equal to 9,000 upon 540 equal to 16.66 grams. So the mass of steam left is 16.6 grams, which can be rounded off to 16.7 grams. So this is our answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.